Hello, we're going to talk about shin splints. We're going to talk about what shin splints is, how it occurs, and what we can do to prevent it from occurring. Okay, so what is shin splints? Basically the term shin splints is it's an umbrella term. It's not an actual diagnosis on its own. It covers every sort of condition that can happen in the tibial area of the leg. So the tibial area of the leg is anywhere in the shin area, so it can be anywhere from the knee down towards the ankle. And shin splints basically covers any condition that happens in that area. So it's quite a broad umbrella term which contains hundreds of different conditions. Now, a very common one is one that we call medial tibial stress syndrome. As the name suggests, it's a condition that is caused by stress of the tibia and specifically the medial parts of the tibia. And it usually occurs in this lower 1/3 of the tibia bone. So why does the pain occur in just this lower third of the bone rather than higher up? Basically, the bone isn't a uniform thickness all the way down. Towards the top here, the bone is quite wide, and there's a lot of bone, and therefore the bone in that area is very strong. It's a strong structure up here. Further down the bone, as we go lower down, the bone becomes much narrower. As a result of it being narrower, it's not as strong as it is up at the top. Therefore, any sort of stress that occurs to the bone, you're going to feel it in the weakest, basically the weakest link in the chain really, which is the lower 1/3 where the bone's at the narrowest. Okay, so how do the excess stresses occur to the bone down in this area? Basically, if we take this cardboard tube, this is a replica of a tibia. If we look at the long axis of the bone, that's the axis which goes the length of the bone. If we apply a body weight to the top of the bone and the ground underneath, the bone becomes compressed. The bone sort of gets squashed. Now, compression forces along the long axis of the bone are what encourage the bone to become stronger. The bone can tolerate those forces very well. So any sort of compression force along the length of a tibia, sort of the bone can tolerate that, it copes with it very well and actually encourages the bone to become stronger. What the bone can't tolerate is bending moments or forces coming in from the side of the bone. So any force coming this way, coming in from the side of the bone, is going to cause the bone to bend rather than be compressed. As a result of that bending, damage occurs to the bone, and then that sort of damage builds up, and eventually you start to get pain occurring. So if we take this tibia here, a force coming in from the side, we're going to get the bone bending. So down the lower 1/3 where the bone's at its weakest, because it's got the very small cross-sectional area, we get compression happening on this side, and we get an extension happening along the outer side of the tibia. That aggravates the bone, causes damage to the bone, and therefore you start getting pain occurring. So you just have to remember, compression of the bone is good. That encourages the bone to get stronger. Any sort of bending moment going across the bone causes the bone to bend. We get compression and extension, and that's what causes the bone to become damaged, and that's what the bone doesn't like. So how do these bending moments across the bone occur? Okay, if we look at this video of the person running, this gait style is what we call a crossover gait. We have a very narrow base of support, so we have one foot landing directly in front of the other, and on some steps the feet actually cross over. If we look at a still shot of the person on the crossover gait, the big red arrow on the right represents the ground reaction force. That's like the impact force of the foot contacting the ground. We've then got the little red line on the left, which represents where the tibia lies. Now, the greater the angle between those two lines, the greater the bending moment acting upon the tibia, and that can be represented with the little yellow line in between the two. So this is the same person running, but instead of having the crossover gait, this person has a much wider base of gait. So instead of the feet crossing over, there's a distinct gap between the feet when they contact the ground. If we look at the still shot of the person running the wide base of gait, we notice that the ground reaction force line is similar to the one with the narrow base of gait. However, the two red lines are much closer together. This means there's a much smaller lever arm between the ground reaction force and the tibia bone, which means there's a smaller bending moment acting upon the tibia.